Hello everyone. This week we're going to talk about network and computer attacks, chapter 3 of your book. So after finishing this chapter, you're going to be able to describe the different types of malicious software and what damage they can do, describe the methods of protecting against malware attacks, describe the type of network attacks, and identify physical security attacks and vulnerabilities. Malware. First type of malicious software. This includes viruses, viri, worms, trojans. These network attacks prevent a business from operating. Sure, that's one thing. It's going to prevent a computer from operating. It's going to exfiltrate data. It's going to encrypt data. Malware is a catch-all term. The book says the goal is to make money. I think that's one of many goals. It's not even a main goal. It depends on who's issuing the malware. Is it a hacktivist? Is it a state actor or an APT, Advanced Persistent Threat Group? Is it someone trying to make money? Sure, that could be a goal, but sometimes the goal is disruption. Sometimes the goal is stealing data or exfiltrating data. Sometimes the goal is to extract money. Sure. Sometimes the goal is to just cause harm, cause public disruption, terrorism. The book says the goal is to make money. Just follow what the book says on any quiz, though. Malware was once targeted specifically at Windows, Linux, and other traditional OSs. It's always been targeted at various operating systems. Again, the goal is disruption. The goal is money. The goal is many. But really, you're trying to cause problems. So a virus. What's a virus? It's a program that attaches itself to another file or another program. I love the connection here they're making to medical terms, so it needs a host to replicate. Doesn't stand on its own. Yes, it does. A virus, I really don't know what they're getting here. No foolproof prevention method. We talk about a lot of the AI solutions that are coming out, and we're getting close. The types of viruses that we have to be worried about are those that essentially mutate constantly, those that encrypt their code. You're right, you could say any of this has no foolproof prevention method, but some of the other comments are a bit shaky. Phishing is not a virus. It is a method of potentially getting a virus out there. Ransomware, yeah, it's a type of virus. So again, jumping back to phishing, you're going to send a fake email. You're going to smish, send a fake text message. Vish, make a fake phone call. Get a user to download a program. That program could be a virus. The program could be ransomware. And it doesn't, ransomware, a type of virus that locks the target system until a ransom is paid. Not necessarily. A ransomware doesn't need to necessarily lock the system. It could be selective. It could encrypt certain files and ask for a ransom to encrypt those certain files, but leave the rest of the operating system alone. But for the book's sake, it locks the system until a ransom is paid. This is an example of a very horrible phishing message. Again, you want to look at the domain. You want to look to see if it's encrypted. You want to see if you recognize the sender, do business with the sender. There's a lot of methods to avoid phishing. I don't particularly believe the phishing email they've shown here is a particularly great example of a good phishing email. But it is a phishing email nonetheless. When you click the link in the mail, you're probably going to be presented with a download that pops into your browser or an ask for you to open something. So what kills a virus? An antivirus. It looks on signatures. So what's a signature? Essentially, you have a virus, which is a PE file or a portable executable file in Windows. It's other executable files in other operating systems. It looks at the file, and it takes a hash of the file. That hash, whether it's MD5, SHA-256, is a representation of that file. It's compared to a database of known bad files. Now, this is obviously a problem with viruses or viri that change their code, encrypt their code, mutate their code. Hashes don't always work. Not all antivirus programs detect based off of virus signatures. You have behavioral antivirus programs that look at what the virus is doing. Is there some weird activity on the system? You have AI-based virus protection programs that look at a multitude of data streams coming into the system to determine if a program could potentially be a virus. Here are some viruses. This is in your book. Some viruses contain email attachments were encoded in base 64. Yes, some email clients required that all attachments be encoded in base 64. Base 64, remember, don't you ever use it as a method of encryption. It's really not a method of hiding. It just looks like a bunch of gobbledygook again because you're changing bases. But yes, if you decode an attachment, you could see if it's a virus. So, sure. This slide is kind of stating the obvious. You should look for hidden computer programs, executable pieces of programming code. Yes, you should look for things that try to hide themselves and mask themselves. Macro viruses. So again, if you're not familiar with macros, a lot of applications allow for scripting languages. Visual Basic for Applications is a common scripting language used by the Windows operating system as well as the Microsoft Office suite. So macros, Apple has its own set of macros, AppleScript, that you can use to perform functions. Essentially, a macro allows you to reduce the number of steps to go from one state to another by automating some of those steps. It's a simple way of programming, also called just scripting. But you can use those script languages to write applications that do nefarious things, and that's where macroviruses comes in. Oftentimes you'll see them attached to a Word document or attached to an Excel file. Even non-programmers can create macroviruses, absolutely. You could be a script kiddie and make one of these things. They often come in templates. You can buy them too. Worms. Worms, a program that replicates and propagates without a host. And I'm sorry, if you're reading this or listening to this right now and you hear this message, I don't know if you've seen the movie Hackers, but the police detective always repeats the same phrase, hackers, infiltrate systems. This is all I think of when I'm reading some of this stuff. A worm is a program that replicates and propagates without a host. So Stuxnet is a great example of not only a worm, but a worm that entered an air-gapped system, code red and configure. They can infect every computer in the world in a short period. They just go from host to host to host and try to propagate over known vulnerabilities in executable transmissions. So, for instance, in Windows, you can perform remote executions, and oftentimes, either through RDP or through remote executions, worms will use those methods to propagate. Here are some examples of worms. Here are some more examples of worms. Infamous worms have cost businesses billions of dollars. Yes, any of these, whether it be ransomware, whether it be a virus, a worm, any business that gets affected by one of these is going to lose potential dollars through loss of operations, affected business continuity issues. Here again, downtime, lost productivity, the fact that you now have to hire someone to fix your problem. Absolutely. You could say make the statement for all of it. Cyber attacks against ATMs, absolutely. I love it's not good, but if you've seen the videos in the attacks on the ATMs and it launches the money out of the thing, this is a serious concern. So you need to watch out for it, need to prepare for it. Trojans, so again, you think of a Trojan horse. It's a program within another package or another program. It looks like it's useful, it looks like a game, it looks like it's a business application, but it's a disguise to either install a backdoor, install a rootkit, hide itself within the OS. Again, it says here, good software hardware firewall identifies traffic on unfamiliar ports. Absolutely. Again, applying to Trojan, viruses, worms, ransomware, any form of malware. You look for different changing behavior to determine whether or not these applications are trying to do something nefarious, or if these applications are even on your network in the first place. Trojan programs can use known ports. Yes, they can use any port. Here are examples of some Trojans. Spyware. Spyware is trying to find data about you. There was a rash of spyware late 90s, early 2000s in the form of some of these adwares. So Bonsai Buddy and the some of these applications that you would download through toolbars. These are forms of spyware. They're on your system to steal data. They're on your system to steal keystrokes, passwords, credit card numbers, social security numbers, anything that identifies you, and they can use that against you. Here's an example. Looks like this was Windows XP, where it tricks you into downloading a piece of software through a modal dialog. I already mentioned adware. Really, this is spyware, but for the purpose of making money. They want cost per impression payments. They want to sell your data. They want cost per clicks. Banner ads, all the great stuff. The real problem with adware, it says it slows down computers, but you have to ask who's making the adware. I mean, these could be foreign adversaries. These could be hackers. You can't necessarily know if adware is just for the purpose of making money. So put it all in the bucket of spyware. It's all unsafe. It should never be on your system. Yes, it's a difficult task to protect against malware attacks, and oftentimes these pieces of malware are being created by nation states. They have the unlimited resources of their home governments to generate this software, hire the best programmers in the world. So it can be super difficult to protect against malware. Sure, antivirus programs can detect many malware programs, but they are not infallible. And they had mentioned signatures, but again, it's behavioral, it's signature-based, it's AI-based. There's different ways of figuring out whether or not malware is present on a system. But it's important to educate end users on looking for behavioral differences in their system. Is something weird? Is something slower? Who to contact, who to call when they do find a problem. Yeah, you could get a pop-up. Again, this is a very old example of McAfee showing the PW crack. It's a pup on the program. I'm looking at it as you're looking at it. So it's you want to make sure every system has antivirus. Another interesting comment is having multiple pieces of antivirus software in the system can actually cause a problem. They can conflict with each other, block each other, thinking that each other is another virus or another application scanning the system, and can actually harm your network if you have more than one antivirus or anti-malware system on your computer. So be careful of that, because these two could conflict and lower the overall value of each system. So we want to talk about user education, structural training. You probably, if you've been employed or even in your Tri-C email, you see that we're constantly trying to make sure that everybody is aware of what a phishing email message looks like. What is it like to get vished? What is it like to get smished? You want to make sure that all employees and management are trained to recognize behavioral differences on their system. This could be recognizing phishing emails or recognizing what a virus looks like on their system. Virus signature database updating recommendations, that's great for home use on a system. You should be doing that at the enterprise level. We want to make sure that everything is automatic based on WSIS or some other update server, whether it's third party. You want to make sure you're always pushing updates. And then sometimes you can have a whitelist or a blacklist. Blacklist, that is where you block specific applications by either a signature or a name. Whitelist is the opposite. We only allow approved programs to run. And then make sure to always update virus signature files. Too popular spyware, Spybot Search and Destroy, that is old. Don't use that. Malwarebytes has been around for a while. There was even an issue, I believe, with Spybot, but you know what? I'm not gonna go into it in the video because I'm not quite sure, but I'll look it up. So this goes back into end user compliance. Ultimately, your job in trying to get users to comply with your security directives isn't necessarily to scare them. Now, if they don't follow the rules, there have to be some set of consequences. I ask in some of my talks, with an employer, when do you fire someone? Do you fire someone after the first phishing email? Or do you fire them after they fall for the fifth? Do you never fire them? What's the bar? If you have zero consequences for users making mistakes, you're not going to get compliance. But, on the other side, you can't just assume your end users understand all this technical nonsense and jargon. You have to translate it to what the business and the people of the business understand. So, yes, security testers need to be a part of it. You need to promote awareness. With some folks, rather than instilling fear, some folks only learn based on the negative portions of policies and procedures. So remember that too. It really depends on the employee. Everybody, though, should be aware of potential threats, and you have to build on users' knowledge. It makes the training easier. So intruder attacks on network computers, an attack, any attempt by an unauthorized person to access, damage, or use network resources. Remember the key word there, unauthorized. And yes, they exploit a weakness or a vulnerability. They look for vectors to get into your network. And an exploit, a string of data intended. An exploit could be an application, it could be a script, anything that takes advantage of a vulnerability or a weakness. Network security, I don't know, it's kind of obvious. It's making sure your network is secure. Computer security, making sure your computer's secure. Computer crime, you are breaking the law. DOS, you've probably heard of DDoS, or Distributed Denial of Service, a DOS. This prevents anyone from using any resource as it was intended. This doesn't have to be involve computers. So, for instance, let's say you take your car and you put it in the middle of an intersection and you get out of your car and you leave it there. Now no one can use the intersection. That is a denial of service. There was a service that was the ability to take city roads. You're in the middle of the intersection. No one can use that anymore. Think about that in the context of any computer. If I hit a web server over and over and over and over and over again and other people can't view that website anymore, that's a denial of service. Attackers are just trying to get people not be able to access the information. They want people to not be able to use the programming. Installing an attack yourself is not wise. Yes, if you are experiencing a DOS attack, and this goes to proof of concept issues in any sort of attack. Your job in terms of the forensic analysis is don't run the attacks. You don't know what could happen. If you find a piece of software that performs a DOS attack, you think it's part of the attack, don't run it. Don't necessarily don't try and get back at a host that DOSes you. So if you know, oh man, this is coming from this specific IP address, we're going to get them back, and we try to perform a denial of service attack on them. Don't do it. That IP address could be spoofed. It's not an ethical thing to do. So again, when you're looking at forensics, don't try and go after the actors. The ping of death. It's a type of DOS attack where you take an ICMP packet or a ping packet. Usually it's more than allowed, and you just keep slamming a host over and over and over again. The host tries to assemble all these packets. It doesn't know what to do, and the thing crashes. So that's the ping of death. This has pretty much been patched in all modern devices. Distributed DOS or DDoS, as I mentioned before, that's where you have an attacker using multiple hosts, oftentimes a botnet or a group of computers that have been taken over to target one single service or website or or business application to take it down. Usually it does so by reducing the amount of overall bandwidth, degrading the speed. And when I said botnet, it says here often participants are not aware that they're part of the attack. You'll get some viruses or malware that jump on a person's machine, and they are used as soldiers in the DOS army to go after a target. A dark DDoS attack, that's a smoke screen, so it's to distract those defending a network while you're trying to do another attack. So it's a feint. So you're attacking this server over here, everybody's rushing to protect it, and then you just waltz over there and get the real server and real data that you want. That is if you're a hacker, it's an excellent sort of attack. Buffer overflow. So this looks at code. It looks at memory in code. And what it does is, certain variables in memory are allocated a certain amount of space. And you have different parts of memory. Some memory is used to store data. Some memory is used to store executable code. When you overflow a buffer, and a program allows you to overflow a buffer, let's say we have a 4-byte buffer. I try to put 5 bytes into that. And that last byte overflows into the next memory segment, which then could be executed by the operating system. So again, it takes advantage of the fact that programs are not checking and restricting specific memory blocks. It takes advantage of the fact that the operating system is not locking people down to specific memory blocks. And this goes back to poor programming practices. So we need to be super careful when we are designing our code, if you're going into any programming field, that you take into account the potential for buffer overflows. Here are some examples of buffer overflow attacks. Eavesdropping. This is where, just like on the phone or sitting, trying to stick your ear to the wall, you're trying to listen to someone else doing something on the network. This is you're trying to grab packets that were intended for someone else. You can use packet sniffers for this, wireless sniffers for this, and oftentimes to defend against eavesdropping, you can use encrypted protocols to make sure that you have that confidentiality attached. You want to make sure you have the whole CIA triad accounted for. Man in the middle, you have a source, you have a destination, 2 points, and I sit in the middle. Oftentimes, this is why you want to make sure that you're using SSL certificates on your websites, because in some cases, on some non-private networks, I can sit in the middle of an attack, or sit in the middle of a transaction and grab data. I am making this video from a hotel room right now. I am on a public Wi-Fi network. I am connected through a VPN that is trusted, that is encrypting my traffic to avoid the situation on this network where someone sits between me and the final destination. Session hijacking. If you have a network session, you've authenticated. What I've done is I try to make both parties think that I'm the party that the source of the destination is communicating with. It's a little bit beyond this course and the book here, but again, the whole point is you receive a session token. I find some way to mimic your token so I can masquerade as you and take over your session. So, physical security. You could have all the firewalls in the world, but if I can get to your data center and plug something in, turn something off, get to your assistant's desk and plug in a USB drive while I'm talking to you, none of this matters. Security is an onion. You have to be concerned with defense in depth. Physical security is the most important security. And I know that people like to argue, well, cybersecurity is more important, physical security is more important. They are complementary. The new term in the industry is cyber-physical convergence. When you look at organizations, how should you structure this? Instead of having cybersecurity under IT and physical security under a chief operating officer, you should have both together as peers reporting to a chief security officer underneath the CEO. So you need to make sure as you're designing your systems, you're taking physical security in mind and complementing it. Same thing with physical security. Physical security designers should complement your cybersecurity designs. Keyloggers, we want to make sure that we avoid keyloggers all possible. So there are pieces of software that sit and just monitor keystrokes. They could be software, they could be hardware. I have some keylogger hardware that I use in some of my cybersecurity engagements. The software of Spyware is a great example, adware we talked about. The other interesting thing about keyloggers is I could log your keystrokes sitting in a hotel room across the way, monitoring the signals that come off of your keyboard. Or I could use a parabolic microphone, and I could listen to your keystrokes if you're on a clicky keyboard or a keyboard that emits enough sound to determine the distance of your fingers to the lengths of the keys. So we talk about software and hardware tools, but I can do this remotely as well, and it's something you should keep in your toolbox. Here's an example of a keylogger or a key grabber, a log that could be used by it. Key Ghost as an example of a tool that can be used for it. Behind locked doors, obviously physical security is number one. If I can breach your physical security, you are owned. End of the day. It doesn't matter. I can get on your box. I can take your box. I can perform whatever I need to do. You need to make sure you lock up your servers. And this isn't lockup. When we talk two-factor authentication in the software world, this applies to the hardware world as well. I shouldn't be able just to take a key and get into a room. You should look at who I am, what I am, where I am. Look at the basics of passwords and authentication and use multiple factors. If you have to use a lock, choose rotary locks. They're harder to pick. And you should always keep a record of who enters and leaves the room, but you should do that automatically if you can, in a way that cannot be edited and that is completely audited. So again, in summary, always beware of network attacks. We talked about the various types of malicious software. Some of the book definitions were a little off, but remember, if you're taking a quiz, use the book definition. Don't use my comments. But in a work situation, use my comments. Different types of attacks, keyloggers, physical security. Security is everyone's responsibility. Gosh, working in the airport world, that's the motto. And sometimes it's hard. The nature of people is to help each other out. Oh, you forgot your key, I want to let you in the door. You forgot your password, I want to help you. Use my account. Don't do it. I know it goes against the human nature. It goes against the want of most people to help each other. But it's super important, especially in this industry. You know how to compartmentalize. Be a good person, right? You want to make sure you're moral in whatever way you're moral or ethical. But when it comes to being a cybersecurity expert, you need to trust but verify at the very least. You need to make sure you're not being lied to, manipulated, and tricked. Because that's what the malicious hackers are doing, right? You're a hacker. Don't let the book tell you that hackers are malicious people. You are inquisitive, you want to learn, you are curious, but in the end, you need to make sure that you're not getting duped. So when it comes to physical security, when it comes to social engineering and masquerading, you need to make sure that you're at the top of your game. You can recognize the truth from a lie. You need to recognize and keep your situational awareness up. So that's Chapter 3. If you have any questions, shoot me an email, and good luck with this week's content, labs, and quiz.